So thank you very much for inviting me. And also thank you to Gabriele, or to everybody really, for summarising my talk quite nicely. I've spent a lot of time trying to think about the needs that we have, both to give a public health message as well as the science behind it, and how do we combine all of that. And one of the problems I think we actually have as carbohydrate scientists is what I call hairy definitions. They are not very easy to reproduce scientifically, and that was well demonstrated by both Gabriele and David, that these definitions, there's always problems with them. And recently we've had the problems with the ultra-processed food, where we know what it is, but the definition is extremely hairy. So when we look at carbohydrates in the food tables, they are based, in theory, on the actual chemical composition. But as David very eloquently proved, dietary fibre or dietary fibres are not all carbohydrate by any means. And I would say cutins, our bran is actually very high in cutin, but this actually isn't realised with some work I did some years ago. So we actually have a lot and quite a variety of what we have. So when you're doing the epidemiological studies, you're looking at these correlations and broad terms, you're actually looking with very broad categories that aren't necessarily correct. And there's this assumption in public health that all simple sugars and starches are easily absorbed and broken down in the upper gut, whereas what actually happens to fibre and the oligosaccharides, they go down to the colon. Of course, we know this isn't correct. There's been some attempt to recognise the different rates of absorption, and this is by no means comprehensive, but we've got Angelis, which is used a lot by industry, and he talks about slowly absorbed carbohydrates and rapidly absorbed carbohydrates, but it doesn't relate really to any physiological outcomes and nothing to do with the chemistry of the food. Quality carbohydrates is our recent one that's often talked about, but it is simply a description of the behaviour of the carbohydrates without any attempt to attach it to foods or chemistry, basically because that's too difficult. And we know that when you look at it from the starch concept, all starch has the same formulation. And of course we've got the glycemic index, which is really useful. It gives a very clear physiological outcome, but we've never been able to actually relate that back to the food chemistry. So, why are all carbohydrates not equal? I'm going one step further than David and saying actually it's not just dietary fibres, it's carbohydrates. And I think we get some clue from where carbohydrates are in plants, and of course when you look at that in relation to the glycemic index, you can start to modulate what's actually going on. So when you look at sugars, starch and oligosaccharides, they're all energy sources for the plant, and they all occur inside the actual cells. Whereas when you look at dietary fibre, it is the outer side of the cells, it's the cell walls, and it gives you that three-dimensional nature of our plant, but it encloses all the energy sources as well as other things. All the other cell contents are in there. And the other thing that's very difficult, as David very clearly demonstrated, is that you have very different chemistry in different plants. You've usually got cellulose as your main scaffolding, but actually the isomeric structure varies depending on the role that the cell actually has in that plant, and that also what it's actually bound to as well. Grains and onions and a few other plants do not contain pectins. They only have hemicelluloses in their walls, whereas fruit and vegetables have pectins. And I use the plural there because that structure varies very considerably between different plants. And all of these actually vary a lot depending both on the plant type and the ripeness of the plant. So, and also actually some of the post-harvest treatment as well will also have some impact. So you've got some very complex chemistry going on within fibre. So from that, we can conclude that dietary fibre is different from the other carbohydrates. We all know that in our heads. It holds those carbohydrates within the cell, and it gives us that three-dimensional nature. It's not broken down by our digestive enzymes, so therefore it will hold on to starch and sugar as it goes through the upper gut. And you're going to have the same value in the food tables whether you have an intact cell or a broken cell. There is no way you can actually tell what's going on. And I think the thing that Gabriele raised, and I think it's really, really important to think of it from a public health perspective, the thing that sets fibre that is different from other carbohydrates but all other nutrients, we have a specific organ in the body. We don't really talk about this. There is one organ actually to digest it. And we need to think about the impact that that has. No other nutrient has an entire organ designed to digest it. The other thing that we need to think about, and again this has been raised already, the impact of what is called resistant starch, but it's also sugars as well, and it's much, much more complex and nuanced than we really think about. When you chew, you will swallow around a 2 millimetre fragment, which will contain somewhere between hundreds and thousands of cells, depending on what you're actually eating. And only the exterior of that fragment will be broken open. So that means that only exterior, that is all that's going to be absorbed or rapidly absorbed in the upper gut, because your dietary fibre, your plant cell walls, are going to remain intact. Now, if you start to disrupt that mechanically by milling or other such like, you're going to actually start to break down the cell walls, but also cooking will start to disrupt the nature of those cell walls, and that's going to make a difference. Conversely, if you're actually drying something, you're actually going to make those cells slightly tougher and harder to break. And at the moment, we can't actually predict what's going to break open and what's going to remain intact. I think that's just a matter of the chemistry needs to happen. I've got a few theories, but I haven't had a chance yet to test them. But that is something, Balash's group are doing some things on that. It's something that we've got to work on. That's a mystery to be solved, but it's not much of a mystery because we know there's chemistry that we will be able to relate to that in time. So in 5 years' time, I hope I'll be able to talk to you about what actually, how that happens. The other thing you've got to think about with, this is going into the quality carbohydrate, that you can't actually differentiate between gelatinized starch, which is very easily quickly absorbed, starch that's been enclosed by the cells, the native or raw starch, and starch that's been retrograded. There is simply a single value for total starch. And I think from looking at things that there's going to be far more resistant starch in our diet than is currently recognised. And tacos, for example, probably have a bit of retrograded starch in, plus a lot of raw starch due to the way they're cooked. Pasta, we know actually the water can't get all the way through. Biscuits are a very low water system, so they actually have a lot of native starch in them. This is from Peter Ellis, and this is actually a semolina porridge from Durham, West Semolina. The first slide is the porridge, and so it's been cooked. Most of the starch has actually been, we think it's probably been gelatinized. It's a fragment because semolina is there in fragments. And you can see it's starches all the way through. The second part is actually showing after 4 hours when they took it out of ileostomy patients, took these fragments out of the ileostomy patients. And what you can see is right in the centre of this fragment, you've still got starch. And it is enclosed by the cell walls. The fragment itself hasn't broken down. But there's only been not much digestion. The little brown bits are actually the dextrins that are slowly being broken down and diffusing out of that fragment. So what you've got to realise that both in cooking and in digestion, if you've got a fragment, and again Gabriele was talking about this, you've actually got to have diffusion, and that is a time-limited process. It's not instantaneous, and everything's got to move diffuse in through each cell wall, each cell at a time, to actually make either water to diffuse in, or if you're digesting, the amylase, and then all the breakdown products need to diffuse out again. So you've actually got a very slow process that is going on there. So I think the key to what is actually going on here, which is around what we classify as quality dietary fibre, is actually how intact those plant cell walls are. And this is really the key. So some of you have seen this before. I'm proposing that we have this definition as a subcategory within the carbohydrate, and actually thinking about how intact our plants, our food is. That's the first type. If you've got a completely intact food, you're going to get those 2 millimetre particles going down, and that's going to have different physiological effects. Once you start to physically disrupt the cells, so semolina, durum wheat semolina in pasta, for example, badly mashed potato, you've got clusters of cells. The third type is ruptured, where you've actually completely broken down those cells, and you've got nothing left of the cell, but you will still have the cell wall constituents. So actually, you can have the same dietary fibre measurement for levels 1, 2, and 3, but very, very different physiological effects, depending on what they are. And then the fourth is the one that I think our gut reaction for all of us is our ultra-processed food. But cornstarch is a good example. You've got nothing of the plant cell wall left, but you may still be able to measure some dietary fibre in there, because there might still be some of the cell wall constituents. And the final one, which I think Gabriele was talking about, is where you actually extract some of the plant polymers and you put them back into food. And there is a noticeable, demonstrable positive impact. So there's been a lot of work done by people in this group with that. But it's different from an intact food. So naturally this divides into 2 main categories: your intact and clustered cells and your ruptured and refined cell walls. Excuse me. And I think the majority of starch in our Western diets is coming from categories 3 and 4, where it's quite rapidly absorbed. And this also explains David's work that he did in the 1980s, where he found the same glycemic index for white bread and wholemeal bread. Being from the UK or from the Antipodes, I use wholemeal rather than whole grain, where you've actually had some milling of the flour, but you don't actually have intact grains. And that, because both actually these cells have been broken down, and so the starch is very easily available. Durum wheat, as I've said, it's a semolina, and there are still quite a lot of cell walls present, so that's why it has quite a low GI. The other thing is, and it's something that I know Joanna Slavin has raised, she mentioned that she thought potassium was important in some of the responses. Well, if you've got intact cells, you're going to have a higher potassium content than you will once you actually rupture them, because potassium is within the cells. The other thing, and this is very much from a public health perspective and a very easy thing to communicate, if you do not have food from categories 1 and 2, you are going to starve one of the major organs in your body. And of course you're going to have health consequences. It's a very simple public health message. The challenges around this is there is no information on the food tables. There's also, when you're coming to the science behind it, cooking will alter cell walls, and it will start to break cells apart and break cells. And I think this is going to be the most difficult division to make between categories 2, where you've got your clustered cells and your ruptured. And if you think about tinned tomatoes and what's actually in tinned tomatoes, you can start to see how that cooking, that processing is starting to break the cells down. On the surface, there appears to be some similarities to the ultra-processed food definition, and I'm aware of that. But this is looking at what should be eaten. It's giving the positive message. We need to eat categories 1 and 2. It's not looking at what should not be eaten, and it's very, very clear from the food what is actually there. This is the biological plausibility of what is actually going on, whereas there's been a lot of work to try to catch up to what's going on with the ultra-processed foods with the addition of all the preservatives, and a lot of it doesn't make sense. Whereas from this, it's a very clear, simple message. So I don't think all carbohydrates are equal, and that they are differentiated through the intactness of the plant cell wall. And what I would like to do is to actually ask if the group would like to publish this definition, debate it, work it through, and publish it as a group, because I think it's something that we need to do as a group to show that we are trying to make some sense of carbohydrate, but also the quality of it. And I have been doing a little bit of work in the background with a data set, and I've come up with this matrix on how to actually classify the different foods. Now, the one thing that I haven't spoken about is this bit. And this, if you've got a mixed food, how do you know whether it would be a clustered food or a ruptured food? And fruit and syrup is a good example of that. And I worked out the 1 to 10 ratio, very, very approximate, and it's something to discuss. If you work out the approximate carbohydrate recommended intake for a 70 kilo person, that comes out very roughly at 300 grams. And the recommendation, going from SACM, because I am from the UK and I did write that, is around 30 grams. So that's a 1 to 10 ratio. And actually, when you look at most foods, it's fine, and you're allowed a biscuit a day. You're not going to miss out on your cookie per day. The other thing that, as Olivia knows, I had a real nightmare over hummus, which, if you think about it, we do think of that as a carbohydrate food. There is dietary fibre in there, and that is going to have an impact. But the main energy source from that is oil. And that actually works out. That and pesto was another one. Again, high dietary fibre, or it's got good fibre in it, but how, what's the ratio? Avocado is another one. And that, using the same concepts, it's around a 1 to 3 ratio. So that's the sort of little bit that given me a bit of nightmare over this, but that's what I've come up with. So that's, I leave that with the group with what they would like to do with it.